Well, hello, Internet peoples. My name is Guy Royce, and this is Redis Monthly Live. With me, as always, is Garth. I'm Justin Castilla.
Party on, Guy.
Party on, Justin. Early backstage, Eric and Justin and I were making jokes about Wayne's World, so that's sort of on my mind. So welcome to Redis Monthly Live. This is a monthly live show where we talk about everything Redis. So we gave it a nice imaginative name, and by we, I mean I. And we stream it every month. We get speakers from all over the place to talk about how they've used Redis or features of Redis. And occasionally we have people from Redis itself give talks. And we try to do a little bit of a mix and have a couple of talks each time. So that's what we have today. So today we've got Justin. Justin is going to be talking. Well, I have a slide for this. Let me bring my slides up. And as I'm introducing everyone. So today we've got Justin talking about tracking smells with Redis time series. I have no idea what it's at, but I have teenage boys, and so I have a good idea what it's talking about. I tell you, man. And we have Eric Brandis. Is that how you say your last name? I should have checked.
It is. You got it.
Nailed it. Doing a talk that you did at RedisConf last year called Crazy Like a Fox, Redis as Your Database. And
that's right, with the 2022 updates. So
and updated. So we get the latest, greatest, the most updated, right?
That's right.
So that's who we've got speaking today. Before we get everything kicked off, we need to pay the Redis overlords, also known as Justin and I. And I just want to mention that Redis Days is happening right now. It's kind of like RedisConf, but it's more focused and a little, not as big, not as long, but just as significant. Redis Days London has already happened. It happened back on the 15th. Coming up next is on the 23rd, which is Wednesday. We have Redis Days San Francisco. And then on the 31st, we have Redis Days New York. Now, if you're not in London or San Francisco or New York, fear not, because these are virtual events, and so you may attend them virtually. And we're specifically trying to reach out to a developer audience here on Redis Monthly Live. And so I'll give you the pro tip that the San Francisco event is the one if you can only make one, is the one you want to go to. So go check that out. Sign up. It's redis.com/Redis Days. And go check it out. So that's all my slides. Let me go ahead and hide my desktop here. And we'll just chit-chat here a little bit. So I always like to do a little segment before we get the talk kicked off where we talk and sort of just get to know our speakers. And so I ask sort of a somewhat random question. That oftentimes I make up on the spot, but this time I'm a little more premeditated. And so it's something Redis related sometimes, but definitely technology related. And so my question this month for Justin and Eric, and I'll answer this as well, is what's the most significant or memorable or a memorable occurrence in which you did something terrible with software, like in production, maybe you brought production down, or you caused some sort of error that's propagated and was found later, something like that. So. And I'll let whoever wants to go first.
Justin, you go for it.
Okay. This one is luckily very annoying, but it didn't damage anything. I didn't drop a database. I haven't done that yet. It's going to happen. But I was working on a free trial sign-up page for a company I worked for about 3 or 4 years ago. And we had a big push for a new product, and we got everybody super excited to sign up for a free trial during one of our conferences. And I screwed up the email validation queue. And one person signs up for a free trial. That's great. They get an email validation. Another person signs up for an email trial. They get an email validation. And the other person got an email validation. So this was a globally released, similar to Redis Days. So we had people throughout the world signing up for free trials. And the poor first person to actually start their free trial, they received at least 1,200 emails, and before he started freaking out and yelling at us, and then I started getting emails as well because I started my free trial. So everybody was valid. Everybody was validated. It was a simple fix, of course, but man, that really lit a fire under my work chair for a second there.
It reminds me, I used to work for a large insurance company here in the city where I'm based out of. And you would get this pattern where there was like an email, everyone in the company email address, and someone would CC that by accident. And then you get the constant cascade of reply to alls.
Yeah, stop replying to all, even though they're replying.
Exactly. You always get to stop replying to everyone, email to everyone. Kind of reminds me of that a little bit.
Yeah, basically.
Absolutely. I don't have a really good one like that. I knock on wood again, now that we're having this discussion, I'm sure I'm going to do something just catastrophically stupid in production, probably tomorrow. But early on in my career, I learned that, production was sort of the sacred thing that you don't want to mess with. And so I had a few close calls very early on, but to that end, these days, one of the things that we do is we make, whenever you're logged into a box in production, first of all, we make it hard to log into the box in production, but sometimes you have to, right? It's unavoidable. And when you are, if it's a Windows box, we have like big red chrome everywhere. So all the windows and everything is just like this bright, obnoxious red. And if it's a Linux box, like the terminal and like the thing that comes up when you first like SSH in is just like all red, like this is production, like don't be stupid. And that is actually, it's like, because there's definitely been times I've almost done some things and I'm like, that's a red window. Like I should probably be careful, And so that has actually, it's saved us more times than not.
That's a pro tip. That is accumulated wisdom.
Because you're going to be, because it's going to be you that makes the mistake always. And so it's like, how can I like preempt my own idiocy and like, what will I recognize,
So everyone, we should do that. Everyone else be like Eric. By which I mean, make everything red, not, drop tables in production.
That's right.
So mine is, I've made a lot of mistakes in my career. I've been writing software for, almost 30 years now. But the one that I'm going to choose to share today is I worked for a retailer and they had a large distribution center, and we had software for the warehouse, and we deployed it and it didn't work, and it prevented packages from being shipped to West Virginia, of all places. The rest of the physical lever on the sorting machine wouldn't. They were just piling up on the assembly line, or I guess they're not really the assembly line, but on the line heading to West Virginia. And so they had to take the warehouse down for an hour or so and redeploy a new version of the software, roll back. So, I took a warehouse down for a large retailer. So, exciting times. So, cool. Well, those were fun stories, weren't they? So I guess we should probably kick this off. Just to let everyone know who's watching, if you have any questions during the talks, just go ahead and drop them in chat. If you're on YouTube or Twitch, just drop them in chat there. We'll see them here, and we can bring them up on the screen just by clicking on them, so everyone can see your questions. Eric's going to be watching for those when he gives his talk to the best that he can. He has it on another monitor. And Justin, you'll be doing the same, I assume.
Yep.
I didn't ask that ahead of time. I probably should have. And so go ahead and drop your questions in chat, and we'll start off here with Justin. Are you ready?
I'm ready to go.
Okay, here you go. Let me slide you into the pole position here and get ourselves out of the stream here.
Thank you. So, so this is going to actually be a kind of a preview of quite a few topics that I'm going to be covering in the next few months with Redis, with our Explainer series and our Head in a Corner series. Tracking smells with Redis Time series. There's a lot to unpack there. Tracking suspended particulate matter over time at the local scale with Raspberry Pi, Redis, and Grafana. That makes a little bit more sense. Basically, I created a Rube Goldberg machine, and I'm now able to tell whether or not I have good quality air coming into that window behind me. So join me as I kind of unpack this. So first, what is Redis Time series? You've probably heard about it before, mentioned in some of our videos or tutorials. It's a module that you can tack on to the core Redis database service, and it adds a time series data structure, which is basically a point of information attached to a timestamp. And this gives us a lot of flexibility on visualization of data. You can determine the average over time, or the minimum or maximum standard deviations amongst like a set or a population. Lots of really cool, just mathy stuff. I've been playing with it for the last 2 or 3 weeks now, and really just kind of fallen in love with it. I was all about Team Redis JSON, but Team Redis time series is a lot of fun. So to kind of start this whole thing off, I live in Northern California, in Oakland, and we have a lot of wildfires within the last like 4 or 5 years. So our air quality pretty much goes to heck. It gets really bad. We have to close our windows. Sometimes we have to tape shut our windows just because the air quality is going to be really bad for us, our house plants, our house pets. And one particular day, it actually stands out to me, September 8th, 2 years ago. There was a really big fire that was blowing smoke way up into the atmosphere over Northern California. And you can see the picture here. It was that red. It was kind of impossible to really convey just how dark it was. And street lights were still on. Birds weren't chirping. Like it was pretty harsh. It was a bummer, and the air quality was absolutely horrible. It affected the entire state for a good day. So that really got me interested. I did a lot of research on AQI. It was kind of like the numerical value that everybody was kind of staring at and refreshing their websites at, just to figure out whether or not you can actually go outside and breathe the air. And right now, outside I have my window open. It's like 1 or 2. It's perfectly, beautiful air. But during the wildfire season, it can get up into the 200s or 300s. And if you're really close to the fires or in the Central Valley, it gets hazardous, where you just really should not even be there. You should evacuate that city. And one of the things that these websites would track is a PM 2.5 and PM 10. 2.5 is particulate matter that is of size 2.5 micrograms or larger. And that is usually wood smoke, wood particulate matter from forest fires. So that's what actually gets into your lungs and gives you headaches, nausea, respiratory distress, pulmonary distress, lots of really, really bad things that we've been noticing. And here, as you can see, these are all the different things that are ultimately factored in for the AQI. And there are websites that we would go to. One of my favorites was Purple Air. They would actually sell a person a sensor unit. They connected to their wireless network, and they would just put it up in their backyard or front yard, and you would use two sensors for just to make sure that there's a consensus, sniff the air, and that would be readily available online. So now we're actually looking at a little screenshot of Pacifica that I took earlier today, and it's pretty clean air. It's pretty good, but it's really cool because this is crowdsourced. So you can actually look at somebody that's maybe like within like a couple blocks away from you, and that gives you a really good sense of like how the specific air quality is around you. I really like that, and I did some research. And they use these guys, the Plan Tower PMS 5003. They use 2 of them, and it's just a very small little sensor. I actually have it right here. It's cute. It's very, very pretty color. And it runs off of 5.5 volts, and it just smells the air, shoots a laser through it, and kind of counts how many particulates are blocking the laser light. It's really, really cool and relatively inexpensive. So I liked it. It didn't have any moving parts that were unstable, and I could stick it outside. So I was like, well, I see an opportunity for me to just play with hardware again and see what I can do with it. So I decided to make my own air sensor. And once I got farther with that, I was like, well, what can I do with this? So this little graphic illustrates my process. You start with the little blue air sensor, and then you can connect it to an Arduino board, or you can connect it to a Raspberry Pi. Now, Raspberry Pi is basically nowadays just a little tiny desktop PC. The one that I have now is 2.5 gigahertz and 8 gigs of RAM, so it can it can handle its own. And also it has wireless, which is fantastic. So I connected my sensor to a Raspberry Pi, and of course you can run Python on Raspberry Pi. And of course with Python, you can run the Redis client with Python. So basically I would take little sniffs of the air, figure out the particulate concentration, and I would send that to Redis Cloud as a data structure. Now, it'd be perfect for time series because, again, time series, you track data over time via timestamps. And these little sensors take a sniff every single second by default. So there we go. I can actually detect the particulate matter in real time, relatively real time, and actually send it to a cloud instance of Redis. And so I was really excited about that. What else can I do with it? So here's kind of like a really quick overview of what happens. So the blue sensor just spits out numbers, the particulates. My Raspberry Pi is attaching an actual timestamp of when it's collecting that data and sending it over to my Redis Cloud instance. Python has a client for the sensor and for Redis. So it's reading from the sensor and then it's sending that data over to Redis. And then Redis actually stores it as a time series data type, which is basically a large sorted grouping of timestamps and values. So that's all that the time series is, timestamps and values. And here's just a quick little overview of what that code just actually looks like. Here I am connecting to my Redis instance for the Redis client, and then I'm creating a PMS 5003 sensor instance. So I have to actually set like the baud rate, the device, address connection from Raspberry Pi, what pins to enable on the GPIO, the little pins inside the Raspberry Pi. Wasn't too hard because there's a lot of people that are doing this in California because we really want to know when it's safe to be, breathing the air outside our houses at any given time. And then I just stuck it into a loop and I kept on sending these readings over to Redis near the end there by adding it to an existing time series data type. So that was cool. And I was like, well, I have this time series and I know that Grafana and Redis are besties, and Grafana, Redis and Prometheus are besties. There's all sorts of really just great visualization software. So this was my first attempt at connecting my raw Redis time series data into Grafana, and it took it really well. It was really easy to integrate with just I made a little Node.js application that served up the Redis time series as an API endpoint for Grafana. Grafana loved it. And now you can see here. Things I learned personally, air quality drops drastically at night because the cool air tends to hug the ground more and there's less movement. And so that cold air pulls particulate matter from the higher atmosphere onto us and the TVs, or I'm sorry, the houses. I also learned that people next door like to run their dryer a lot, and it's actually near my sensor, so I can tell whenever they're drying their clothing. Also, I love my downstairs neighbors cooking. I can also detect the cooking, which is pretty interesting. Also, it could detect when I was making chicken fried steak over the weekend for brunch. So it's very sensitive and very accurate. But the thing is, me cooking a chicken fried steak and my neighbors drying their laundry is not very significant. So I want to actually take the average over time rather than just all the raw data. So there's actually, and I'm not going to go over too much into creating, instantiating, and manipulating a time series because that's for actual later video. But there is this really, really cool feature called create rule, where you create a new time series object based off of one that you already have. And what you can do is take a sampling over a specified amount of time and create an average of it. So let's say I want to take an average of the particulate matter over 5 minutes instead of every second, or 10 minutes instead of every second. And that just gives you a smaller time series to deal with. So if you're sending that over to like Grafana is very happy because it's much faster. Also visually, it's just smoother and easier to understand. It's not, it's not just a very volatile looking graph if like a bird decides to burp right next to your sensor or something like that. So here we see two time series objects: my house, which is just my house, and then my house : average : 5. So that's just going to take the average of all of my time series entries in 5-minute increments. So that makes it much easier to send and receive and visualize and consume. And so here we go. This is the better, improved, and faster version of the air quality around my house. And again, there's just the intermediary API. We actually have it on Redis Labs Devo, our GitHub page for things that you can pull down and try. Grafana has their own Redis data source instance as well that you can play with. This one I found worked out really, really well with minimal changes. So if you ever want to try this at home, check it out. And if one works, then why not have two? So I actually bought a second sensor, and I have them both in the front and the back of my house. So my reasoning is I live in a long row shotgun Victorian. So I was always wondering, does the air quality differ from behind my house and in front of my house? Because the wind can't always like go through it. Turns out it can. The one in yellow is behind my house, and the one in green is in front of my house. And that makes me think, what are the factors? Well, I live in front of a road, so the road is maybe giving me more particulate matter, tire, bits of tire up in the air, and exhaust and things like that. And in my backyard, I have more trees, and it's a little bit calmer air, and it's a little bit more verdant. So things to look at, and that kind of tracks with what I'm seeing here. But I'm no chemist, so I'm not quite sure. So yeah, I think it's really cool, and then it allows me to know the air quality of my surroundings. And right now, it's really nice. I have my window open because it's not fire season. But in a couple of months, we're going to be at risk of having more wildfires. So I'm going to need to know if it's okay to breathe the air outside. So what can I do? I can create a bot to notify me via email or SMS, or just make a really loud clanging noise when the air quality is not good, or when it actually is, the all clear to open back up. I can get really, handy and connect some servos to some of my windows. They're just, sash windows, so I could theoretically just raise them and lower them as it goes on. I can also have this connected to power relays to turn on my air purifier just as a safety precaution, even if my windows are closed. Also, I can contribute to Purple Air. I can contribute to an even more crowdsourced open source website where people are just contributing their own data. And also, it is kind of making me think about, how I actually impact the air quality around me. I have a fire pit in my backyard, and I do get that Californian guilt of having a fire in my backyard, for coziness. And you sort of like think about what actually affects your air around you. So, maybe let's not have that bonfire while the air has been very still and it's just been sitting on our city for so long. So that's what I've been working on. It's been a lot of fun. There's a lot of possibilities with the time series. So I'm just doing air quality. So you could do temperature, you could do movement, you can count how many people go in or go out of a location. If you're like a retail store, you want to track customers over like purchases, things like that. The possibilities are endless. You can use sensors on server temperature, or you can do like server traffic. You can do real-time monitoring with Redis time series. And you can also use Redis time series to monitor your Redis instance. So it gets very meta really quick, and it's kind of fun. I really like it. And integrating with Grafana was surprisingly easy. So yeah, what's new for me? I am working with Simon on RU204, story querying and indexing JSON at speed. So it's going to be an extension and an enhancement of RU203, which is querying and indexing with Redis Search. Look forward to a Redis time series explainer. So I will go over creating and manipulating Redis time series data in depth with commands and scenarios. And then, yeah, I'm also going to include a technical walkthrough of running Redis Pi with Redis, running Redis on Raspberry Pi, and integrating a Raspberry Pi into like a larger Redis network where all the systems are sending data over to a central Redis in the cloud. How I did that with my current system. And of course, how to connect it to Grafana so you can actually play along at home and you could, check the air quality of your house. So, and as always, you can always reach out to me or anybody else at Redis on our Discord channel. Go ahead and see our courses. They're always live. They're self-paced, and they're fantastic at Redis University. And then, yeah, always check out the Redis Explain videos and all the Redis Monthly Live videos. They're all syndicated on Redis YouTube. So there's always stuff to learn with us. So yeah, thank you very much to listening to my California stinky air rant. And yeah, Guy, back to you.
Excellent. So this is just so much fun. I've actually, I have an idea too. So I've got this. I'm totally gonna. I can't find it now. I've got these software-defined radios that I like to play with. They're just little dongles that you plug into your computer, and then you hook them up to an antenna, and it can read. You can use your computer as the tuner, basically. But there's a lot of data formats that you can capture, and one of the data formats that I discovered I could capture is my gas meter or my water meters report and the gas meter reports and the electric meter reports. Like just every minute it'll send out a number of whatever the meter reads, and it'll pick up all my neighbors too. And that is just I totally want to use this and hook it up to Redis. I was going to say Redis streams, but Redis time series now, because I think that would be really interesting. Like you could watch the gas and water usage go up and down in your neighborhood, sort of in aggregate.
Yeah,
it'd be fun data to play with.
Yeah, it's really interesting how much data you can create and observe just on your own.
Yeah,
things you never thought you would know. Like, what happened at 3 a.m. last night?
Yeah.
Where you my whole neighborhood farted or something. I have no idea. It was just nasty.
Was there a parade and no one told me? Yeah.
I live right next to an estuary, so that's the only thing I can think of is just the algae got really gross and dead or something. But yeah, cool stuff. Really cool stuff.
So there are a ton of questions in chat from Aziz.
Woo.
You've probably answered some of his questions already, but a quick scroll through maybe. I don't think we have time to answer all of them, but a quick scroll through would be, I think, worthwhile. And you can just click on those, right, Justin?
Yeah. Let's see here.
Yeah, I'm disappointed I can't find my little radio to show it off. But...
Right. Well, here's a good one. Let's start from the beginning. What type of Redis setup do I have? On my Raspberry Pi, it's just the Python client. And then I am actually using, because I insist on doing this, I'm using a free Redis Cloud instance where I'm sending all my data. So you get 30 megabytes of data to store on a Redis Cloud. And the size of Redis time series is very small. You can start off at 4 kilobytes and it expands within there, and then it doubles if you actually have to do so. But again, Redis time series, it's just timestamps and a number. So it's never going to get massively huge. Also with compaction, you can make these time series smaller. And retention times, which I'm probably getting a little too ahead of myself. With retention settings, you can actually automatically limit the size of your time series, which is really nice. The message over HTTP, yes. With Redis client, that's one thing, but the Redis Cloud to go to Grafana, it's over HTTP with my little Node.js API. And again, a lot of this will be revealed with my Redis time series explainer and the actual tutorial for the whole thing to set up. What is the effect of wind in calculation? These little sensors just suck in air with a little tiny fan and then sensor it and then blow it back out. So whatever the wind is carrying, it's just what the sensors are going to grab. And there's a really good document sheet on the PMS 5003. So I recommend everybody checks it out. And One last Aziz gem. This is true. In Grafana, it is quite easy to set up alarms. Yeah, because that's what it's for. It's fantastic. I've been woken up before by Grafana when I was on call. Love that at 3 a.m. So yeah, it is really easy to set up alarms already with Grafana. If you want to do like visualizations and just notifications, Grafana is your one-stop shop. If you just want to roll your own, just as a good exercise, you can always use Node.js or whatever framework you enjoy. So, and then yeah, Aziz, thank you for participating so much. All these questions I'll definitely be more than happy to answer on Discord, and also a lot of these will be answered in the explainer and the tutorials that I'm rolling out. So this is going to be like a longer term series. So cool.
Lucas had a question as well that I think is worth answering here. So he wanted to know if you could use other data input as sensors, as quote sensors unquote. I think that's a yes, probably, but
yeah.
I'll let you.
Yeah.
On it.
You could use pretty much anything you want that creates data. It could be, number of traffic visits or traffic hits to pages, things like that. Anything that produces a number at different times that is statistically interesting, you can use. So I'm using air quality sensors. I could use volume meters. I can use proximity sensors. You can track stock data as a huge usage. I know of the Redis time series as well. So anything you can think of.
I'm going to track Bitcoin with it.
Go for it. Yeah, it's a lot of fun.
Very cool. Very cool. Well, thanks, Justin. And I happen to know that you risked life and limb to put this talk together, didn't you?
Yeah. So I wanted to make sure that this sensor had the best sniffing angle, I guess you could say. So I climbed up onto my deck roof and was lightly nailing this to under an eave, and kind of lost my grip there because I'm an engineer, not a carpenter, and took a little bit of a tumble onto my deck. But thankfully, I was perfectly fine. My ego was a little bruised more than my actual backside. So I worked hard for this presentation, everybody. I hope you enjoy it.
Yeah. So Justin is all in.
Yeah, I'm in it to win it.
Yeah. Well, excellent. Well, thank you very much, and thank you for your vertical sacrifice. Excellent. So, Eric, I think you're up next. Are you ready?
I think so. As ready as I'll ever be, anyways.
Are you crazy? Yeah. It looks like you might be. Yeah. Let me slide you up here into the pole position, and then you can have the stage.
Perfect. Well, thanks, Guy, for having me on the show today. So this talk is called Crazy Like a Fox, Redis is Your Primary Database. And I actually gave a version of this talk at RedisConf just a few months ago, but I've expanded it a bit and updated it for 2022. So hopefully there's still quite a bit of new stuff if anybody's caught it. My name is Eric Brandis, and so I am the founder of two software companies, one of which is called Track.js, and the new one that we're going to talk about today is called Request Metrics. And so they're both very simple software as a service products, and they do kind of one thing well. Track.js is a JavaScript error monitoring tool, and Request Metrics is a web performance monitoring tool. So kind of like Justin's talk, we just do a lot of time series data over and over. And so why am I in this Redis Live Talk to begin with? And so I want to start by saying that I really love Redis. And the reason that we're even here is because my business partners and I, we got together one day. Track.js have been going for years. It's a stable product. And we're like, we should build a second product. And we're like, what software do we not hate? And, we had spent many years corralling a very unruly Elasticsearch cluster. We'd all spent time in the bowels of the Fortune 500s as enterprise consultants. So we've seen all sorts of terrible things done in the name of software there. And Redis came up as the one tool that has never really hurt us. It always works mostly like you think it would. And so we also love the low operational complexity of Redis. It's really simple, especially in master replica mode. Distributed systems just make me a little bit nervous, right? And so sort of having one primary and then one or more replicas, it's easy for me to get my head around. People have been using Redis in super high performance environments for years. We've been using it on Track.js for years. And the other great thing about Redis is that even though it's not a database, it does have multiple data types, so you can do a little bit more interesting kind of data storage and data querying. And of course, the last main reason to use Redis, right, is that is blazingly fast. And so we thought, okay, well, what's the one thing you should never do with Redis, right? And so Redis has all these great qualities. But the thing that you should never, ever do with Redis, everyone will tell you, is use it as your primary database. But we were thinking about that. Why should you not use it as a database? A lot of people tell you, well, Redis isn't durable, right? It doesn't make any durability guarantees. You might lose data. Everything's in memory. It will push and persist things to disk, depending on the settings that you specify. But there's no kind of transactional guarantee, right? It's sort of best effort. Your store size is limited. You've only got so much RAM on a box. And so the minute you fill that up, that's it. Your Redis instance can't get any bigger. There's no relational capability in Redis. Not really. I mean, there's, maybe some modules that sort of attempt it, but nothing like a classic relational database. And your querying capability is also, a little bit limited. There's no generic query language like SQL or something else. But maybe you don't care. Maybe you just really like Redis, and maybe you're like, it's really fast. And so maybe that's all I care about. Like, what if? And so we all kind of got together and we're like, well, Redis is great. It's super fast. Yeah, it's got all these limitations, and everyone says you shouldn't do this thing. But what if we did it anyways, right? Like, what if we just said, let's try it and see what happens? So the question is, can you build an entire SaaS product using only Redis? And the answer is you can. And so we built it and we launched it like 6 months ago or 7 months ago. And it's called Request Metrics. And it is a web performance monitoring tool. And so on the screen, you can see, a few of the screenshots. I've got a few more screenshots here. Like, this is a dashboard, right? So once you hook up the agent and start sending us data, this is your dashboard. You can look at different time ranges, desktop versus mobile. And we store things like your performance, your core web vitals, all the different resource origins that make up your page. So, when you load a web page, you're maybe going to 20 or 30 different domains to get JavaScript, CSS fonts. And all of those can affect the speed of your website, where your visitors coming from, that kind of thing. So we track all of that data, and it all gets stored in Redis. And we can draw really cool, kind of like Justin's talk, we can draw really cool time series charts. And so that's a lot of what we do, is just show you performance over time, or show you, user location over time, or whatever. And that's all in Redis. And we did not use Redis time series actually for this, but we'll talk more in a second about how we actually store all this data. And as you can see, we've got a lot of data, and we've got it for all of the pages in your application, right? So for each page that comes in, we're monitoring all of this data. So Web Vitals, Geo, all that stuff. And then we can also roll it up and give you kind of an overall view of everything. Like, here's an example of the geographic breakdown. So you can do this, right? But why did we choose to keep going in light of sort of, this is a bad idea? And really, once we started building this, we were amazed at how fast everything was. So because of the way we set up the data, which we'll talk about more in a minute, everything is blazing fast. Most of the pages load in under 500 milliseconds, right? Even to draw all of that data. We have had no issues with Redis, knock on wood, in terms of reliability. So far, there's been, no time where Redis was the reason something didn't work. And, we've used Redis for 7 or 8 years, and we've upgraded over the years, but we just, for another product, upgraded from a really old version of Redis to a really new version, and everything just worked. So all of the old, APIs and everything just continued to work. And that's really important to us as kind of small business owners. We don't have time to be messing around with all the different, kind of upgrade treadmills that these different software products have. And the other big thing for us was we want to keep this product low cost. There are a lot of big enterprise web performance vendors out there, like AppDynamics and some of those guys. And we wanted to be in that lower cost space for smaller and medium businesses primarily. And then kind of the last thing is we actually don't care if we lose data once in a while, which sounds terrible. But when a website is sending us 1 million page views worth of data per hour, if you lose one or two, like, is that the end of the world? You know what I mean? Like, everything's in aggregate. So it's like, how important is one or two things? And not that we lose data, but we just sort of like said, hey, if that were to ever happen, it would be something that we could handle. It would be okay for our use case. So I want to talk really, really quick just about the architecture of the whole system. So Redis is the database, but there are a few more moving pieces. So we have a JavaScript agent that you would put on your site. And that JavaScript agent would send all of the data that we're going to track to an Nginx front end. The reason we need to put something in front of Redis, right? And Nginx was the other piece of software that came up on the list of things we didn't hate, and mostly works the way you think it's gonna, at least once it's configured. And so all Nginx does, so all this data, we've got thousands of requests per second coming in the front door, hitting Nginx. The only thing Nginx does is log it to a JSON log file. So it literally takes the payload that comes in the front door and writes it to disk. Like, that's all Nginx is doing. And then we have a processor job written in .NET Core that writes to Redis. And we have a jobs service written in .NET Core that will do things like alerting, right? So it's always watching the Redis instance to say, hey, is performance degrading? And we do various like summary emails and that kind of thing that it will also send out. And then we have a reporting UI. And so that also talks to Redis. So you can see here, I don't know if you can see my cursor, but literally everything talks to Redis. It's the only data store we have. And so a lot of people ask, well, what do we run it on, right? What kind of infrastructure do we use? And so I guess there's this really cool Redis cloud thing, which we did look at briefly, but we are old school and we like bare metal hardware. So our entire production environment runs on 2 fairly beefy physical servers. One is the master, one is the replica, and that's it. They're 4-core Xeons, but they're fairly modern Xeons, and they're pretty quick, particularly with single-threaded performance. There's 2 gigabits of total network connectivity, and even with a few thousand requests per second, we're still nowhere. We've still got 1.5 gigabits left, and then each box has 64 gigs of RAM. And so, just over the last 30 days, our app, even though it's new, so we're still growing, and we're growing at quite a clip. But we've processed 300 million page views, 600 million endpoint timings, 3.3 billion resource timings. And if the system were to run at full speed, so like in a stress test or something, we could do 145,000 things per second coming in the front door. And as of right now, the system sits at about 6% CPU, and everything runs on these 2 boxes. So the jobs, the processor, the UI, everything. And so it averages about 6% over the week. And the whole thing costs us less than $300 a month. So sometimes people like to see that kind of stats and those sort of things for these businesses. So for at least for now, while we've started, we've got quite a lot of headroom left, but it's really not very expensive. So let's talk about processing the data. So like I said, Nginx actually takes in the request from the client, and it writes out a formatted JSON log file, right? And that's essentially what you're seeing over here on the right. Is basically the kind of thing that Nginx is going to write to disk, and we actually write it in a JSON format. So like the log file that comes out of Nginx is actually a JSON file, right? And then we have a .NET Core service that reads it, and then it basically processes each line, kind of deserializes it, and then it aggregates everything for that run, and then pushes it back to Redis as a single batch. And so we have multiple machines. We have 2 machines. We have the, kind of the master and the replica Redis instance, but both of them process data at the same time. And both of them are active at the same time, and you can read from either of them. But one thing that we had to do is we had to figure out a way. So we've got all this data coming in. We've got .NET processing it, but we need to write it to Redis. But to keep things simple, we wanted the processor to run on each box. So like however many boxes there are, they're processing their own data. So when they write to Redis, we want to make sure they're not stomping over the other box that's writing to Redis. And so we did another thing you're supposed to never, ever do yourself. And we wrote our own distributed lock mechanism for write coordination. It is not Paxos compliant, but for us, it works great and it's blazing fast. And, writing to Redis usually takes less than 150 milliseconds per cycle. And we run a cycle every 10 seconds, just to keep. So that's how long it'll take from when the data comes in the front door to when you'll see it reflected in the app. It would be no more than 10 seconds. And actually, we found for us, the Redis time is one of the smaller things. The JSON deserialization is actually oftentimes sort of the biggest long pole in our processing. And so I'll talk more about JSON later. So here's another screen, right, that we can build in our app. And so I want to talk about the data model a little bit more. And I want to talk about the data model that builds this screen. So this is like for an individual page, right? So this is for, like, in this case, I just took the screenshot this morning. This is for the login page on trackjs.com. And so here you can see we've got the load performance, we've got traffic, we've got geo, we've got the web vitals, which you actually can see. You know, our first contentful paint isn't very good, and it's actually, you know, like, I guess it's getting a little better, but it's still like not good. So that's something that we need to work on. But so how do we draw all this data out of Redis? So the way we've done it, and I don't know if this is the right way or the wrong way, but the way we chose to do it is each page or resource or endpoint or whatever you're looking at in our system, it has its own key in Redis. And we aggregate all the data by some sort of time range. So we don't store any individual events. The lowest granularity we get is a minute. So when the data comes in, it all gets bucketed into that minute's worth of data. And so that's kind of the highest fidelity that we store. And as the data gets older, so after, say, a week or so, we're going to start aggregating all of that by hour and eventually by day. So you'll lose a little of that fidelity as things get older, but we can store a lot more of it, and it'll give you great trending over time. And so here is, I was in Redis Desktop Manager. If you've ever used Redis on Windows or the Redis Desktop Manager GUI, you might recognize the screenshot. But for each, so for example, for a page, this is what a key would look like. So we've got your customer ID, we've got your application ID, and then we've just got, is it an endpoint, is it a page, whatever. And then we have the hash, I believe it's the murmur3 hash of the page. And so that's where all of the data is going to live. And so within this, right, so these are all hashes. So that key is actually a hash under the covers. And the key is always a computed timestamp. So it tells us two things. It tells us this is the the bucket for a specific day, and then here's the value for all that data, right? So there's ones for minute, there's ones for hours, and we have a job that goes through that I'll talk more about later that just kind of it sort of coalesces and aggregates over time. And so if we look, here's what the value actually looks like. So this is sort of a truncated view. There's a lot more value in here, but it's just a big JSON blob, right? So we store this JSON blob inside this key. And we've shortened, as you can see, all of the properties, right? Because we're storing JSON, and JSON is verbose. And I'm going to talk about a couple things specifically. So number one here, this pink one, you can see like the interval here that we're talking about is a day. So when the UI reads this, we know this is a whole day's worth of data. If you look at number two here, this is really goofball looking, right? Like, what is this sort of nonsense? So this is obviously base 64 encoding, but we're using a special hyperlog log counter that serializes to a very small size to keep like unique counts. So how many unique users saw this page on this day? And it's a hyperlog log counter that we can actually roll up over time. And so like, uniques won't get double counted. And then we've got some other so we've got these like comma separated values. Like, what's with that? So we will talk about that here in just a second. And so the big thing that I was kind of alluding to is that space is at a premium. So we shorten the JSON property names. We do that special unique counting just to keep things smaller. And we have created a number of homegrown, again, probably a bad idea, but homegrown like data shortening formats. And so one of them is this comma separated list. So I just wanted to talk briefly about like one part of the UI and how it relates to the data model. So like, for example, to draw this chart, right? So this is a chart of the website's performance over time. And we've bucketed that performance. So we've got these different buckets over here. So there's, your page load was less than a second, 1 to 2 seconds, 1 to 3 seconds, you know what I mean? And all the way up. Then how many of each of these pages were in this band? And so to do that, for each of those different little time slices that we have, we store a bucket like this with all of these different bucket boundaries. So we can actually look in this array and we can say, okay, 4 of these came in the first position. Okay, that was 0 to 1,000 milliseconds, right? But we don't store this array. We store this thing, which is this goofball, comma, separated guy. And you can see, if you look at, this is what it looks like in Redis. This is the exact same data, these two things, but one is a lot shorter. And when you do this over thousands and thousands of these different hash values, it actually adds up to like megabytes or gigabytes of space saved. Again, this is sort of a goofy thing that we know there are, tighter over the wire formats than JSON. But I'll talk a little bit later about why we still haven't switched to any of those formats. But the nice thing is too, this is just an array. How we interpret this array is up to the code. So, pages will have a different set of boundaries and endpoints versus resources, right? Like, because a page might take longer in general to load, but like an AJAX call should be a little bit quicker on average. And so we've actually, like these bucket boundaries are only for page loads. And for endpoint loads, we have a different whole measurement set. So that's kind of how we draw a chart like this and keep that data to a minimum. We can talk about reading the data. So once we've written all this data, one of the things we like about Redis is the speed. And so when we draw a page like this on the right, we just read everything every time, right? Like it's super inefficient, but Redis is so fast, and the network is so fast between these machines that even if we read from the replica and we're on the other machine, it's still less than 500 milliseconds to draw the whole page. We're okay with dirty reads too, so we don't care if the data has been replicated. Only because Redis replicates so fast that we're talking about a lag time of maybe 1 to 2 seconds. One thing, I don't know how many people are .NET developers, but if you are a .NET developer, kind of the client that you use to talk to Redis is called stackexchange.redis, and it's a great client most of the time. But if you're doing a lot of async await, you need to be really, really careful because it doesn't actually do what you want it to do. And I'll talk about that more in a second. Because to draw a page like this, we might be reading 1,000 keys, and each one of those keys has maybe 200 or 300 hash fields, depending on the time range that you've selected. So we're talking about sort of thousands of requests to Redis. But like I said, it's so fast that we just do it anyways. And we there's a lot of options to clean that up and make it a little bit more efficient, but we haven't needed to yet. So I do want to talk just real quick. On this previous slide, I said, hey, be careful with the Stack Exchange Redis client and the async await stuff in .NET. And so if you're not familiar with the .NET async await, basically when you read from Redis, kind of like in JavaScript, you get this task back, this promise, more or less. And you can wait for it. And there's all sorts of syntactic sugar in the language to make that easier. But what'll happen is if you queue up 20,000 gets to Redis, .NET will actually queue up 20,000 tasks all at once, even though it can only run a handful at a time. So it doesn't provide any back pressure whatsoever. And so what we would see is we'd be doing these big reads, and all of a sudden we'd start getting Redis timeouts because Redis is like, well, hey, you had 5 seconds, and this task has been sitting there for 5 seconds, and nothing's happened. And what you'd see is if you went wide enough, you start to see resource exhaustion or a lot of resources being used on the server because .NET wasn't being smart about it. The whole selling point of tasks in .NET was that it would manage concurrency for you, except that at least in this case, you have to manage the concurrency yourself. And so that's what we did. So we actually built this work queue. This is the actual work queue that we use. So we can set a max degree of parallelism. And so we've tuned this over the months to see what kind of works best talking to Redis. But we had hoped there would be something like this in .NET, and unfortunately there wasn't. Finally, with this way that we've laid out our data, how each page resource endpoint is a key. If we want to get all the data for a given key, we can just do an hgetAll. And then once we get all that data, we can filter it and slice and dice it and do whatever else we want on the app side. So that's kind of what we do again, because we're lazy. There are times where we'll get specific, kind of time ranges out of a given key, but a lot of times it's easier just to get everything and then figure it out on the app. So that was a lot about just like the performance stuff. The last thing I'll just talk about real quick with respect to the data model is we use it for literally everything. So like as an example, all of our users are also stored in Redis. And the key is literally called the user's key. And we have a customer's key. And we have like a notifications key. And so like anything else that you might need in a database, we store in Redis. And so like, here's an example, right? It's all in JSON blobs. It's, another hash value, right? With a computed key. And that's kind of the main story of our app, right? It's just hash values and computed keys and a lot of JSON. I did mention briefly that we do run some jobs. So we run roll-up jobs every hour to kind of, take the older data and move it to a higher level of time granularity, or I guess a lower level. We have a truncation job that will purge old data. If someone is just sending us crazy amounts of noise or something, we may also clean that up. And these are all .NET Core services. We run them all using systemd on Linux. So .NET Core, the great thing about it, if you're not familiar, is that it runs now not just on Windows, but also on Linux. And so we decided we're going to roll the dice and try it on Linux. And so far, it's been working spectacularly. It has been rock solid and reliable, knock on wood. And we do, just because we don't trust it, we don't trust anything that Microsoft does. So we have a third-party monitoring app, which also monitors this just to, make sure everything's working. Let's see. We've got no relationships, basically. So the deal with Redis is, we chose not to use a relational database. And because of that, there's no referential integrity. There's, no like looking something up by relationship. So we actually chose not to do any of that. If somebody somehow puts bad data into our Redis instance, we actually have a job that we will run that goes through once a day and just sort of reconciles everything. And so that's we call it the orphan hunter job. And basically, we don't want to spend the time in code, writing in that sort of referential integrity. So we'll just sort of fix it later. Yeah, and sorry, I'm going a little fast just because it's almost 2, and so I wanted to make sure people didn't have, if they have other things going on, I didn't want to keep you. We've got some administrative stuff. We use SSH tunneling to access dev and prod. We do backups every hour, and so our backups are literally taking the dump RDB and pushing them to the cloud, and then every hour we actually restore prod to dev too. And so actually from that perspective, it's like the easiest backup and restore scenario imaginable. It's really it's my favorite thing ever. We don't use, so a lot of people ask us, what would you think about Redis cluster? We did, but we like the simplicity of master replica. We like to use the multiple database feature. So I think by default, Redis has 10 databases. We actually use those for different things, and you can't use those in Redis cluster, which is too bad. And also, we've run Elasticsearch for so many years that I really the word distributed system sort of gives me the chills. We don't use Sentinel. So again, a lot of people say, well, that'd be, you should use that at least if you're going to use master replica. We don't, because that would need at least 3 boxes, and we only have 2 boxes. So again, we have a third-party service that just makes sure everything's up, and that works great for us. And we also don't use PubSub because we just haven't found a use for it. And sort of finally, we have some future plans. So I talked about JSON. We're all in on JSON. We do use the fastest .NET JSON serializer and deserializer, but it's still slow. So we have considered looking at message pack or protobuf instead of JSON. The other option is DoorDash has done a lot of work with compression in Redis. And so they've written some really good blog posts and talked about their results using things like Snappy or LZ4 to do that compression. And let's see, finally, kind of the last, we're reading all this data all the time, right? So when you draw a page, we're going to Redis and we're just getting tons of data. And it's still really fast, but it's not efficient. a lot of this data, once we've coalesced it into hour chunks or minute chunks, even like if it's more than an hour old, there's not going to be any change to that data. And so one of the things we could do is actually put all of the, the data that we're using for an actively logged in customer, we can actually store that in the app's memory. So you're kind of taking a double hit on the memory, but memory is pretty cheap. And then we could render pages in 100 milliseconds or 50 milliseconds, which would be kind of cool to have an app that moved that fast, since it is a performance monitoring app after all. So finally, it's 2:00. So sorry, it went a little long, but the final thoughts are, for us, the speed is the thing that has been the killer feature. It really makes a lot of the other things that we do super easy. You never have to worry about is this call to the database expensive? It's not. It's Redis. It's fast. The limitations are workable. We kind of know what they are. We know that space is going to be, probably our biggest thing to be concerned about, but we're kind of managing that from day one. And for us, it's been the lowest administrative overhead we've ever had. And we're a small team of developers, and so none of us want to get up at 2 a.m. and deal with a pager. And so Redis has really been great from that perspective, and allowed us to just focus on building the app and not keeping the app alive. So that is it. Yeah, so it looks like there was some stuff going on in the chat. I could see it on my screen over here, but my eyes aren't good enough to read it at the font size. So.
Well, Aziz had a lot of questions. We had some questions from Anked as well. Let me see if I can find some good ones in here. We'll look at the most recent ones, because lots of times, people ask a question and then you're about to answer, when you're giving a talk.
Yeah,
so.
yeah.
Here. Well, this is a nice comment. So Annika says he would love to see a full series on this. So I think that means you need to start streaming on Twitch.
Yeah, well, and so we actually, so if anybody cares, actually, we actually recorded ourselves making the very first version of this. Like, we literally recorded ourselves in Visual Studio typing this on Zoom. So if anyone's a glutton for punishment, literally us writing all of this code is public on our YouTube channel. So we did edit it. It's not just because some of it, gets pretty boring, but we did edit it for content. So it should be fairly interesting. But it's
2 hours of Eric typing. Yeah.
Yeah. I use a mechanical keyboard, so it's really, you can hear it. But no, it's we're certainly happy to be as transparent as we could look at code. We can do anything. So if anybody wants to, feel free to email me, if you have specific questions or whatever. So how do you,
sorry, go ahead.
How do you present the front end?
Yeah.
So the front end is all ASP.NET Core. And so we use server side rendered everything. It's no single page application or any of that. And we use a little JavaScript library called PJAX, so that you'll do a full page load the first time you go. But then as you're clicking around the website, we actually just AJAX in whole blocks of HTML and replace those. So we're using the .NET Core or the ASP.NET Razer templating engine is what they call it in Microsoft world. And we've used that for years. And we really like that PJAX style approach where you're just jamming HTML onto the screen. It's really fast and it works pretty slick.
So Lucas also wants to encourage you to start streaming. So
I don't know if anybody needs me doing that. I don't know.
All you need is a beard and a Twitch channel, and you're good.
I know. I'll put one on. I'll get one that I can glue on before I stream.
So we are actually streaming this particular program on Twitch right now, and we have half-baked plans to do some live coding on Redis's Twitch channel.
Oh man, if you guys ever want, I love pair programming or live programming, so I'm perfectly happy to do that anytime. It does not bother me.
I will hit you up for that.
So, no problem.
And shameless plug of my own stuff. I actually do stream coding at twitch.tv/Guy Royce. So if you're looking for more programming streamers, I haven't done it in a bit. I did the Advent of Code, which was challenging.
Cool.
But yeah, so
it'd be fun to do some competition type stuff too, or you have a little problem to solve, and then it's 2 different people different ways to kind of go about it.
We're going to do the code up a Bloom filter smackdown. Who can code the fastest Bloom filter?
Oh man, that presupposes how to code a Bloom filter.
Well, I'm stacking the deck in my favor.
I do want to shout out one of the series that we did on StreamYard, which is this streaming service for RU101, our university course. Our community manager, Suze, and our dev advocate manager, Simon, and we went over RU101 and covered a lot of different topics. And it's like a conversational setting such as this. So if you have taken or you want to take RU101 and you want to get a little bit more of a human and developer perspective on it, check out that series in our YouTube channel under Redis Inc. There is an entire playlist that I created dedicated to that. So yeah, had to shout out Redis University for that.
Yeah. Yeah, I have to admit, Eric, the whole time I was watching you talk, I was thinking, this is a time series problem.
Yeah, it's what it is. No, you're absolutely right. It's just that we need so much data for any given point in time. We actually did look at that, but then like the key explosion would be so great. Like there'd just be like millions of keys, and that has its own problems. So
well, excellent talk. I can see why you were selected to speak at RedisConf last year. So,
thank you. Yeah, no, it's a fun. It's we always like to do things that people tell you should never do, right? And so I'm just like, why is that? Let me see if I believe you. So
you can learn a lot doing that. I mean, this is sort of a thing that I like to do little coding exercises sometimes, just when I'm learning a new language. Everyone codes up FizzBuzz when they're learning a new language. And I was learning Elixir at the time. And Elixir is a pure functional programming language. I don't know if pure might be a strong word, but it's a functional programming language. There's really not a concept of objects or anything like that. And I've got a coding exercise I did called the Evercraft kata that I created about a decade ago, where you code up the brains of Dungeons and Dragons. And the requirements that I have laid in it are really geared towards object-oriented programming, because you got a lot of nouns. And trying to do something like that in a functional language is not really what you should do, right? But in the process of doing that, you start saying, oh, this is how people came up with the idea of learning what an object-oriented programming like the person who came up with the idea of object-oriented programming went through this process of something like what I built in a functional language and said, hey, what if?
Yeah, there's got to be a better way.
Right. And so I learned something really profound in that process by doing something I shouldn't have.
Yep.
And so break the rules, people. Learn.
Because it helps you learn when you should follow them. Because I mean, in general, I would agree. Don't use Redis as your primary database. But if you want to, like, where are the sharp edges, right?
Yeah, exactly. Looking here, Annika has a, can I also give a talk? Reach out to me, email me, guy.royce@redis.com, and we'll make that happen. So we're always looking for speakers. I saw that there, and always looking for speakers. It's a meetup basically, and it's finding speakers is one of the big challenges. So if you're interested in giving a talk, please do. So, well, we should probably wrap this up unless anyone else has any questions. Eric, do you have anything else you'd like to say?
No,
that was anything you want to plug?
Thanks for letting me talk. It's always nice when somebody's willing to let me, get up here and be opinionated. So
yeah, fantastic job. Appreciate it. And Justin, thank you for falling off a roof for Redis.
I bleed red, which is also the same color as the Redis cube. So just
that's right.
Stay tuned for more content about time series in our YouTube channel. You should be getting an email if you subscribe. Also, I'll announce it on our Discord channel as well.
So coming up next month, we have Nava Levy. She actually works for Redis. She's going to be doing a talk on using feature stores, using Redis as a feature store for machine learning, which I think will be quite interesting. So come check that out. It'll be on April the 18th at 2 p.m. Eastern time, and I believe that will be 8 p.m. Central European time if we're back on the proper time zone, daylight savings time syncing thing. So that's what we have coming up next month. And then if you want to make sure you always catch Redis Monthly Live, go to meetups.redis.com/Redis Live. and join there, and you'll get an email saying, hey, we're going live in 2 days, and sign up, and we're going live here real soon, so that it'll remind you to watch. You can also subscribe on our YouTube channel at youtube.com/RedisInc. And if you give us a follow on twitch.tv/RedisInc, you can, you'll be notified then too. So, and of course, join us on our Redis Discord server. I always announce this here as well, but if you've got Redis questions, you want to go deep and have a nice conversation with a lot of us Redis employees and non-Redis employees that are there to just help and answer questions. We've got a great community. How many people are we up to on our Discord server, Justin? Do you know? I think it's like 6,000 maybe.
Yeah, it's pretty up there.
Yeah.
Super active too. Or there's always a conversation going on in one of the channels.
Yeah. And of course, give us a follow on Twitter as well if you want to see what's going on. Apparently our logo got disappeared from the slide here. I don't know how that happened. It's probably incompetence on the person who created the slides part, which would totally not be me.
Oh,
yeah. I mean, yeah, it's totally me. So that's pretty much what, oh, and then the last one, this is, wow, my picture's disappeared. This is the slide that says Redis Monthly Live needs you. And so, Aniket, this one's for you. So hit me up. And with that, that was Eric and Justin. So thanks a lot, everyone, for watching. Thanks a lot, Eric, for hanging out with us and talking. And thanks, Justin, as well.
my pleasure.
And,
yeah, thanks, guys, for having me.
Yeah, absolutely. Any final words before we kill the stream? I mean, shut it down. We're not actually killing it. Fine. Fantastic. So thanks a lot, everyone. See you next time.
See ya.
Bye.